In this video, we will discuss evaluating limits via the limit laws. To start, let me state the four most commonly used limit laws. To do so, suppose that c is a constant, and the limit as x approaches a of f of x, and the limit as x approaches a of g of x both exist. Then, the first limit law, the limit of a sum or difference is equal to the sum or difference of the limits. If you have a limit of a constant times a function, that constant can be pulled out front of the limit so that you have the constant times the limit of the function. The limit of a product is a product of the limits, and the limit of a quotient is the quotient of the limits, as long as that limit in the denominator is not equal to 0. Intuitively, we can think of these limit laws as telling us that we can do exactly what we would like to do with limits, as long as it makes sense to do so. Now, the more interesting case is when we cannot directly apply the limit laws. When that occurs, we have to reach into our algebraic tool bag and use techniques related to factoring, combining fractions, using conjugates, etc. Now, the review problems associated with the calculus resource sheet give several fantastic examples. Let's consider such an example here. Let's evaluate the limit as x approaches 1 of the given function. My first thought process is, well, what happens when I go to plug in 1? Well, if I take the limit in the bottom, we see as x goes to 1, the x minus 1 goes to 0, so we cannot directly apply our limit laws. So instead, we need to use some type of algebraic simplification. And in this case, the easiest algebraic simplification that we could do is to factor the numerator. So it factors very nicely as x plus 6, x minus 1, and this allows us to cancel off the troubling x minus 1 that we had in the denominator. So now we are simply left with the limit as x approaches 1 of x plus 6. Now we can directly apply in 1 and get something that makes sense. So we can use our limit laws. So the limit of a sum is the sum of the limits. So this would be the limit as x approaches 1 of x plus the limit as x approaches 1 of 6. Well, for the first limit here, as x approaches 1, our outputs x are approaching 1, and the limit of a constant is that constant. So the value of our limit in this case is the number 7. Now, in the last step here where we evaluated the limits, we used a few more of our limit laws. So let me finish by stating the remaining limit laws. So the limit of a function raised to an nth power where n is a positive integer, well, you can take that limit and plug it underneath, so it's the limit raised to the nth power. The limit of a constant is that constant. As x approaches a, the limit of x is going to be a. Combining together 5 and 7, the limit as x approaches a of x to the n is a to the n. And 9 and 10 are essentially telling you the same thing, that a limit can be plugged underneath an nth root.